Hi to all. Now I am going to explain about active elements. Active elements. In previous class, we have discussed about passive elements. Those are resistor, inductor, capacitor, and their VI relationship, and also measured or calculated energy as well as power. Okay, so coming to capacitor, it is a storing element which always stores the energy in the form of electrostatic field. Inductor, which stores the energy in the form of electromagnetic field, and resistor dissipates the energy in the form of heat. Okay, so previous class VI relationship of passive elements completed. Now active elements. So active elements which can gives the supply to the circuit. Okay, so these are the energizing elements which can supply the some energy to a circuit. So for practical consideration, battery and generator, these two are the practical examples. Those can, from that we can collect the supply from battery. So our cell phones are working based on the batteries, and generator which can gives the electricity to our home appliances. Now coming to normal consideration, normal example here, current source and voltage source. So example for active elements are current source and voltage source. Okay, so in practical point of view, battery and generator, those two are the examples of active elements which can give the supply to the circuit. Coming to normal ideal consideration, here we are considering the voltage source and current source are the examples of active elements. So active elements are nothing but which can give the supply to the circuit. Suppose I am considering one normal RLC circuit. Here we are giving some source. This is voltage source. So this voltage source is nothing but active element. From that only we can, in this circuit, some amount of supply apply to this circuit. Okay, so now these three are the passive elements. This is active element. So active, with the help of active elements only we can give some amount of supply to the circuit. Now coming to classification of active elements. For the point of view classification of active elements, here in active elements, the examples of active elements are current source and voltage source. Now coming to voltage source. So voltage source we should consider two considerations. One is ideal case, another one is practical case. Coming to ideal consideration, first of all, first one is ideal voltage source. Ideal voltage source. Okay, after that practical. Coming to ideal is nothing but here it gives 100% efficiency and it gives zero amount of losses. Okay, so then only it gives maximum amount of efficiency, 100% efficient. That's why that term call it as ideal. There is no losses present in that ideal case. Okay, so for this ideal voltage source, here voltage source. So here I am considering this is the voltage source. Okay, now this voltage source is connected to a two load terminals. This is a load. I am assuming one load here, and this is the source. Okay, so voltage source I am applying. This is negative, this is positive. So when I am applying some source to this load, it is nothing but load. Okay, so when I am applying some source to this load, here any change in the second parameter means here when I am applying some voltage, some current is flowing towards the load. So irrespective of change in current, there is no change of voltage source. Okay, so voltage source, it does not depends upon any other factor in the load terminals. So here when I am applying the source voltage, it produces some amount of current that is flows towards the load. Okay, so now coming to characteristics, here I am considering on x-axis, here I am considering the current. So this is towards the load. Okay, now coming to voltage, on y-axis I am considering voltage. So this voltage represents the across the load terminal, so consider it as VL. Okay, so irrespective of change in the current, there is no change in the load voltage. So this VL, it is always constant, it gives the same as that of supply voltage. Okay, so this is a constant term, it does not change irrespective of change in the current which is flows towards the load terminals. So this is the ideal consideration. In this ideal consideration, very important bit question. So in an ideal voltage source, it has zero amount of internal resistance in ideal voltage source is 0. In ideal voltage source is 0. Now coming to second consideration, this is A and this is B. So that is practical. So practical means here somewhat some losses are appear. So not exactly ideal, means not exactly the efficiency is not nearer to 100, less than 100. Okay, so practical voltage source. So here for coming to practical consideration, always in practical voltage source, it is always having one resistance, it is in series with the voltage across the load terminals. This is nothing but load terminal. Here I am considering the load. Okay, so here this resistance is nothing but RS, source resistance, and this is call it as voltage source, negative to positive, and this resistance call it as source resistance across the load terminals. Okay, so always a practical voltage source having some internal resistance which is in series with it. So now due to this connection of resistance, here the amount which is flowing, the current flowing towards the load is somewhat change, means the current, when I am changing the current, the voltage across the load terminal is vary. So how it can vary? Why? Because here some resistor is there. So this resistor which always dissipate the energy in the form of heat. So some voltage drop will be occur in this point. So that's why not exactly equal to source voltage at load terminals. So here on x-axis I am considering current, that is load current IL. Now on y-axis I am considering the voltage. So if the change in the current which is flows towards the load, the voltage is, this is for ideal consideration and this is for practical consideration. So for due to the load source resistance, due to the source resistance, the output or the load voltage should be decreases slightly. Okay, so this gap ela ochindi when this is due to the drop of current and series resistance. Okay, so that is I into R, source resistance drop. So I into R drop, so that's why the line which is somewhat slant, it is less than that of the ideal consideration. So this value indicates the VL. So VL is not exactly equal to VS. Why? Because some voltage drop is appear across this resistance. So that's why due to that drop voltage, so we get the final voltage across the load terminal is this one. Okay, so for ideal consideration, there is no internal resistance. It gives zero amount of internal resistance. So irrespective of change in the current, there is no change in the terminal voltage. That is nothing but VL. So that's why it gives a constant characteristics in between VL and IL. Now coming to practical consideration, always a practical voltage source having some series resistance. So always this voltage source having a series resistance, it is across the load terminals. So now I am considering the current on x-axis and voltage on y-axis. So here when we are changing the current in this one, so due to the some drop, there is somewhat a drop which is not equal to the exact value of the source voltage. Okay, so these two are ideal voltage source and practical voltage source. Coming to current source, current in current also again ideal ideal current source, ideal current source. So ideal current source, so ideal is also nothing but it is 100% efficient, so there is no losses. So now in ideal current source we are representing the current source in circle direction, circle symbol, and here I am considering the arrow mark. Okay, upward arrow means the direction of current is upward direction. So now a practical current source always having a maximum amount of a maximum amount of a maximum amount of parallel resistance, parallel resistance. So why I am considering maximum amount of resistance here? Because here this is the load terminal, this is the load, this is a load terminal. Okay, so here the load voltage is VL and the load current is IL I am considering. Now this is the main source, that is current source represented by IS. Okay, now this current source having parallel resistor as well as load is also parallel. So that's why this current is total current for these two branches. So that's why this current is up to here, that current is same, that is IS, and it is split into two parts. One is flow towards the resistor, source resistor, another one is current which is IL which is flows towards the load. Okay, so now if this resistance is maximum, this resistance is maximum, the current flowing through this path is 0. So the current which is flowing in this path is 0. Okay, so that's why the total current, that is source current which is directly flows towards the load. So at load terminals, irrespective of change in the current, there is no change in the terminal voltage. So that's why here I am considering the x-axis as well as y-axis. On x-axis I am considering the load, terminal load voltage, and on y-axis I am considering the current. So here if we are changing the terminal load voltage, the current it is exactly constant, that is IL which is equal to source current IS. Why? Because here in this path the current is equal to 0. Why? Because here this resistance should be having infinite maximum amount of internal resistance. So that's why here there is no current flowing through this branch. So it acts as like open circuit. So there is no current flowing through this circuit, this point. Only this total current is goes towards the load. So that's why we get the characteristics IL that must be equal to IS. Okay. Now coming to practical consideration. So I am considering B. So here one key point is there, that is an ideal current source having an internal resistance that is equals to infinity. This is internal resistance. Okay. Now coming to practical consideration. So for practical current source, practical current source. Here always this path is having maximum infinite, then only the current is 0. Now but practical consideration it is not possible, so it has somewhat less than the infinite resistance. So that's why some amount of current which is flows towards the parallel path. So here the current source is, okay, and it is having a parallel internal resistance, but it is not exactly equals to infinity, it is less than infinity. Now this is the load terminals, this is the load terminals. Here we are considering the VL, load voltage, and the current flowing through this branch is IL. Okay, due to this internal resistance, that is RS or RI, so it is not less than, it is less than infinity. So that's why some amount of current is flowing in this branch. Okay, so due to that there is total amount of current will not be moved to the load. So that's why here on x-axis voltage, when we are changing the load voltage, here the current that gives I, it is a constant value. Actually it is for ideal consideration, that is IL equals to IS, but coming to practical consideration it is somewhat a drop due to this resistance. So due to this resistance the current is IL here. So this drop is due to I into RS drop. Okay, so this is for practical consideration, this is for ideal consideration. Okay, so these two are the current source as well as voltage source. These sources are also called as independent sources. Independent sources. Independent sources. So again another one is dependent sources. So total sources are represented with two classification. One is independent, another one is dependent. So here current source and voltage source, these two are comes under independent sources. These independent sources are represented with the circle shape. Represented with the circle shape. So see here it is also a circle shape, it is also a circle shape. We can indicate like circle shape only. Okay, now here so active elements are which can give the supply to the circuit. So a practical example is nothing but battery and generator. Now coming to normal consideration, current source and voltage source. So these two are independent sources, those are represented by circle shape. So those are again classified into ideal consideration and practical consideration. So ideal is nothing but it is the output, the load must be constant value which does not depends upon the another factor, that is current. Now coming to current source, always an ideal current source having infinite internal resistance, ideal voltage source having zero internal resistance. Coming to practical, due to this resistance, somewhat resistance appear across the series with the source, so that's why this drop will occur. And here also due to this resistance some drop is occur. Okay, this is practical consideration, these two are the ideal consideration. So now these four are comes under independent sources. Now coming to dependent sources. So dependent means one factor is depends on other. Okay, one factor means voltage is depend on current in that circuit, current source also depends on the voltage source. So those are nothing but dependent sources. So here the total dependent sources are four types. Okay, dependent source, dependent sources. Okay, dependent sources are represented with the diamond shape. Represented with the diamond shape. Okay, these are depend means voltage source is depends on current source in that circuit, current source is depends upon the voltage in that circuit. So here based on that consideration, totally dependent sources are four types. In that first one, voltage dependent dependent voltage source. Voltage source. Second one, voltage dependent current source. Current source. Okay. Third one, current dependent current source. Current dependent current source. Fourth one is current dependent voltage source. Okay. Totally dependent sources are 4 types. One is voltage dependent voltage source. Shortcut, voltage dependent voltage source. Okay. So here voltage dependent current source. Now current dependent current source. Now current dependent voltage source. Totally 4 types. So how can we represent this voltage dependent voltage source? So it is basically voltage source. So here I am considering one diamond shape, and it is basically voltage source. So plus minus symbol. Now which factor it is depends on voltage. So now this is the symbol of voltage source. It is depends on some factor, a constant of V. Okay. So voltage dependent voltage source. Voltage dependent voltage source. Now coming to second one. So here also it is also denoted with the diamond shape, but it is basically a current source. So represented with the upward or downward arrow based on the direction. So this is the current source. It is depends upon what voltage. So current source is represented with Is. It is depends on voltage. Okay. So voltage dependent current source. This is the symbol of voltage dependent current source. So voltage dependent current source. Now coming to third one. This is current dependent current source. So representation of current. This is the diamond shape. It is a basically current source. So, okay. So then we depend అవుతుంది. It is depends on current. So Is is equals to K into I. So current dependent current source. Now last one. This is here basically it is voltage source plus minus, and it is depends on current. So voltage source K into V. Okay. So it is voltage source based on the current. So I am considering here current. Okay. Current dependent voltage source, current dependent current source, voltage dependent current source, voltage dependent voltage source. These all are depend on current. One source is depends on another factor, another source, another current, another voltage depends on current, or voltage depends on itself. Okay. Current depends on current source, current depend on itself in that circuit only. Okay. So these are represented with a diamond shape. Okay. These are the different types of dependent sources. So coming to active elements, dependent independent sources both are completed. Thank you one and all.